Lesson 37 today. We're going to deal with area of combined polygons. Let me show you what a combined polygon looks like. Combined polygon looks just like this. It's a polygon that we don't necessarily have a name for, but it's made up of polygons that we do have names for. Quite simply, this one is a rectangle with a triangle sitting on top of it. So since we know how to find the area of a rectangle, and we know how to find the area of a triangle, if we have enough information, then we should be able to figure out the area of this whole thing. We just add these two pieces together and we'll have the total area. So let's find the area of this combined polygon, or some call it a complex polygon. All right, so the area of a rectangle is base times height. Base of this rectangle is 12 feet and the height is 6 feet. So the area of this red rectangle here is 72 square feet. All right, now we got to find the area of the triangle. I'm going to outline it in green here. Okay, the question is the base and the height of this triangle. We're not given this distance right here. Okay, from the end of this triangle to the end of the rectangle is 8 feet, and the entire bottom is 12 feet. That means this entire distance is 12 feet. Well, 8 plus whatever this green line is should be 12 feet, so we know that's 4. Let's use a similar line of thinking to find the height of this triangle. Okay, the whole distance here was given to us as 10 feet. This shorter distance is 6 feet. If we just do 10 minus 6, then we'll get 4, or 4 plus 6 is the entire distance, 10. So the height is also 4. Won't always be the case, but we have an isosceles right triangle there. We'll do 1/2 base times height. Base 4. Height is 4. Area is 8 square feet. So the total area of this combined polygon, or complex polygon, would be the area of the rectangle, 72, plus the area of the triangle, 8, which would be 80 square feet, not 8 square feet. Let's fix that. 80 square feet. Not too much to it, right? As long as we can find the area of a rectangle and the area of a triangle, shouldn't have too much problem. All right, same idea with this one. We don't have a formula for this one yet, but can we break it up into parts that we do have formulas for? Sure. Okay, if we can divide this up into a rectangle and a triangle. Okay, so the rectangle is base times height, 8 times 3. No problem, 24 square meters. Triangle, we got a little bit of work to do on this, okay? For the triangle here, we have to know what this green line is, this height. And that is 3, because 3 plus 3 is 6. So we're doing 1/2 base times height. 1/2, the base is 8, height is 3. Base is 8, height is 3. So the area is 12 square meters. So the total area of this figure, we'll find out by just adding the rectangle to the triangle. 24 plus 12 is 36 square meters. So to find the area of combined polygons, you combine their areas. And when I say combine, I'm talking about addition. This one's a little different, okay? Find the area of the shaded region. So let's look at this a little bit differently. I'm looking at this as a full triangle that's getting a triangle chopped off of it. Okay, so let's find the area of that big triangle first. Area of this red triangle, or the big triangle, is 1/2 base times height. Okay, the base isn't 40, so be careful. The base is 80. And the height is 40. Base is all the way across 80. Height is 40. So we've got the area of this red triangle is 1,600 centimeters squared. They told us up here the dimensions are in centimeters, so be aware of that. Now, what about this triangle that we're chopping off the end of it? Let's find the area of that. So 1/2 base times height again. Base is 40. Height is 20. All stuff we can do without a calculator here, guys. 20 times 20 is 400 square centimeters. So I said I'm chopping it off, separating it. And we should know that separation means subtraction. So the shaded region here, the shaded area, would be the big triangle minus the small triangle. So 1600 minus 400, which is 1200 centimeters squared. So a little bit different than the first two we did where we added the areas, and hopefully you see how this one's different. Okay, we're subtracting an area because there's a piece missing, a piece that we don't need the area of. All right. Directions say use a calculator to help estimate the area of a lot with the given dimensions. The dimensions are in feet. Okay, not sure why I need a calculator yet, but let's go about this the same way we went about the first two examples. I say a rectangle with a triangle. Okay, no big deal. Let's find the area of that triangle. Oh, here's the issue right here, is that we don't know the base of this triangle. We know its height is 100, but we don't know its base. Okay, we can't use 110 for the base because then this distance right here would be the height, and we don't know that either. So we can do the Pythagorean theorem, though, and figure this out. Okay, the legs are 100 and b, so we'll go 100 squared plus b squared, and the hypotenuse is 110, so the sum of those two legs squared should equal 110 squared. 10,000 plus b squared is 12,100. B squared is 2,100, and that's where the calculator comes in. That's why they told us to use a calculator, because they want us to do the square root of 2,100. It's going to be an irrational number, so we'll just estimate it here. We'll call it about 45.8. Okay, now we have the base of this triangle. Okay, so let's do the area of the rectangle is base times height. 70 times 100 is 7,000 square feet. The area of the triangle is 1/2 base times height. We just found out the base was 45.8, and we know the height is 100. .8 times 50 is 2,290. So the total area of this lot would be the area of the rectangle plus the area of the triangle. And we could say this is about 9,290 square feet or 9,300 square feet. Heck, we already rounded once. Why not again? Okay, 9,300 square feet, close enough to 9,290 square feet. We already rounded to get to the base of this triangle, so it's actually a little bit more than 45.8, so it's going to be a little bit more than 9,290 anyway. All right, so a little bit of an intro there to combined or areas of combined polygons, and we'll practice this a lot over the coming days, and definitely going to see it real soon on a test. So good luck, and come in with your questions tomorrow.